How's everyone? I'm Chevlin, and I'm going to be talking about the magic of motion capture technology. So first off, what is motion capture? And to put it very simply, it's imagine you have a digital mirror that copies everything that you do. Very basic term. The basic concept of motion capture is you first capture your human movement in 3D space. Then we translate that movement data into a digital format. And then finally, we apply that digital movement data into a virtual character model. You can apply to a robot, or you could just simply use it for analysis. You can see there's kind of the process where you start off as the human model. You take the skeleton, well, the points, and then map it into a character model. Before I explain in depth what motion capture does, we first need to discuss the three main types of motion capture. The first one being optical motion capture, which is probably the one that all of you are familiar with. When you guys think motion capture, you probably think movies, video games, you know, the dots on your face, the balls on your body. That's optical motion capture. The second type is inertial systems, where you cover your body in small electronic devices that contain accelerometers, gyroscopes, magnetometers, and you combine all of the sensor data to kind of determine the position and orientation of your model. Where optical motion captures rely on cameras and sensors, inertial only uses sensors to determine everything. And then finally, you have your computer vision motion capture systems, where you only use cameras, no sensors involved. This is by far the most accessible. The bar is low of entry. You don't have to break the bank because the optical systems cost a lot of money. So you don't have to spend a lot of money, and you can still do cool things with motion capture. But to go a little bit more in depth about how motion capture works, specifically for the optical motion capture. Optical motion capture involves two main components, your cameras and your reflective markers. First off, what you do, you have to get a bunch of high-speed cameras. You have multiple. You set them around your model, and you have to surround your capture volume to get as many angles as possible for the best data, obviously. Once you set up all the cameras, then you have to go to your model. You have to set up your reflective markers. The reflective markers is actually the key to everything. Without them, you actually don't have a cool motion capture system, because it's the reflective markers that the camera actually follows. Once you've laid all the groundwork down, you can then start rolling. You can start rolling the cameras. They'll track your reflective markers. And these cameras usually shoot from about 60 frames per second to 1,000 frames per second. So that's usually a lot of data. Once you are satisfied, you've captured everything you need, you think, okay, fine, I've captured the motion. Then you can chuck all of that massive amount of data into a software, and it's going to do its best to triangulate a 3D position. And at the end, if you've done everything correctly, you should be left with a precise digital skeleton of movement. Fantastic, great success. But where do you actually use motion capture? I touched on it earlier, but probably the first thing that comes into your head is entertainment. But it also has other uses, like in sports, healthcare, and scientific research. Just briefly, I'm going to touch on the entertainment industry. So they mainly use optical motion capture. And probably the first thing that comes to your head is a movie like Avatar, which kind of revolutionized motion capture. Before it, there really wasn't that good of use of motion capture in CGI, generated graphics. Avatar was the first. The director, James Cameron, even coined the term performance capture, because he took the traditional motion capture, which was purely the movement, and then he combined the facial expressions and the emotional nuance of the actors as well to combine it, and he coined it performance capture. That's fine. Obviously, we have games like God of War, the recent one, 2018, and also God of War Ragnarok, which all the character acting is using optical motion sensor. And it comes out fantastic. You actually think they're real. Now into sports, motion capture can actually help you with a lot of performance insights. Like, for example, if you're a runner, a sprinter, a long jumper, you can actually get your optimal stride parameters by using motion capture. If you're a footballer, you can get your foot strike patterns. If you're a golfer, you can get the power generation of your shots and the consistency, things like that. In healthcare, they actually use it for something really cool. They use it for development of prosthetic limbs. So what they do is they attach a motion capture sensor onto an able-bodied person, someone who has all their limbs. They monitor, they track your data, they see what you do in your normal everyday use, and they can map that data onto a prosthetic limb for someone who doesn't have that limb and can do what's called a phantom limb intention, where they don't have that limb anymore, but they know how to use it. And through motion capture, they can transfer that data. Very sick. And in the world of scientific research, they do things like animal movement studies. I included the slide because I thought it was very cute. There's a little cat over there, and they're monitoring it and making it do hurdles. Very cute. What can we do in the future with motion capture? There's plenty. What I think we could do, we could have home systems that you control using motion capture. So you don't have to use your voice like, okay, Google. You don't have to use the lights on. You can purely use motions. There's even scientific research being done on using motion capture using radio waves. So now you don't even have to set up cameras. You can track your motions through the walls using radio waves. So we can control your whole house without setting up any cameras, purely with your motions. Obviously, we can transfer the motion capture from humans onto robots and teach robots to have human-like dexterity. So we don't need any reinforcement learning, have robots falling up and down, falling on their faces. We can train them from the source, us. We could use motion capture for things like real-time sign language translation and other accessibility tools for differently abled people. These are a couple of demos that I made just messing around with. This is specifically the computer vision, because I don't have thousands of rands to spend on optical sensors. But yeah, you can do things like this. This is pure, yeah, this is just overlaying the skeleton. Yeah. That's me having fun. Nah. Okay, that's one. Then this was my attempt at making a sign language translator using South African Sign Language. For time's sake, I basically only use the first couple letters. So if you see there, I'm making the symbol for A, symbol for B, and I'm tracking, I don't know if you can see it, the skeleton on my hand. It's tracking the position of my fingers and each of my joints and my fingers, basically. I have another demo that I can show you if you give me a sec. It takes a while to boot up, but basically I can control the volume of my computer using, yes, yeah, got you. Okay, share my screen with sound.
For real, I'm pretty from a cellular. No, say a lot. No. They never had a pretty girl from Joburg. See me now, and that's
So you can do
with the drama, unless you pour the wrongs up. They say it doesn't get
things like this.